In this video, let us all know about what is central force, its properties, and some of the examples for central force. Why central force is so important in mechanics? There are many systems in the universe that involves central force. By studying central force, we get to understand many natural phenomena, especially the motion of the heavenly objects. Let us start by knowing what is central force. Any force which is always directed towards or away from a fixed center is called as central force. And the magnitude of the central force depends only upon the distance between the fixed center and the object. We can represent the central force by mathematical expression F is equal to F of r into unit vector r. The small f of r is nothing but it is the function of the distance r, and r cap is, we generally give it as an r vector divided by r mod, which is nothing but a unit vector along r from the fixed center. Next, let us quickly discuss what are the properties of central force. A central force is always a conservative force, which means the net energy of the system is constant, which establishes the total energy for a system involving central force is conserved. The angular momentum J is also always a constant, or we can call it as a conserved quantity for the systems involving central force. The motion of a particle or an object under the central force is always restricted to a plane only. So, which means it will not involve the third dimension. Hence, the system possesses spherical symmetry. Since the motion is only in a plane, the system involving central forces possesses spherical symmetry. The central force will be an attractive force if the function f of r is less than 0, and it is repulsive if the function f of r is greater than 0. Now let us look into the examples involving central force. To study the motion of the planets with respect to sun, because the motion of the planets with respect to sun comes under central force. We all know all the planets revolve around the sun with sun as a fixed center. Hence, we have a central force playing a role here. And the motion of the satellites about Earth. So, we can generalize these as Newton's inverse square law of gravitation, and the motion of the planets with respect to sun is all governed by Kepler's law. Next, the motion of the two charged particles with respect to each other, or Coulomb's electrostatic force between two charges, comes under central force. Then Hooke's law of spring, that is the Hooke's law of elasticity, also involves central force. The van der Waals force between neutral atoms and molecules in a gas, any force or potential of type 1 by r power n are all come under central force. The examples quoted here all are mostly natural phenomena. To understand this, we need to understand the central force and its behavior.